All right. So today we're talking about classes and object, as well as this big idea called object-oriented programming. Okay. So the idea here is we're going to take you beyond just sort of solving problems step by step, line by line by line by line. Okay. Our programs are still going to be able to run line by line whenever we call different sections, but we're going to open up brand new ways of solving problems and stuff like that. So this was a revolution in programming and the way that people solve programs was this idea called object-oriented programming, or you'll see it in textbooks and other places it says OOP, object-oriented programming. Although I've titled the lesson here Classes and Objects because that's a little bit more real. That's kind of like really what we're going to be dealing with. So together we're going to create and we're going to explore classes and objects, and then at the end of class, sort of as a way for you to demonstrate you know exactly how this stuff works, you are going to design an ogre class. Okay? Now, I think I say right here, when I'm using the word class pretty much for the whole rest of today and forever, I'm not meaning a school course, okay? So I'm talking about something different when I'm talking about a class. All right? So, first up, why use classes? In fact, you can see there at the top of that document, there's pretty much all the questions that we're going to be dealing with today. So, we're going to deal with why, we'll just go through here. So, first off, why use classes? Well, at some point in the history of programming, the programs got bigger and bigger and bigger and bigger, longer and longer and longer. And the problems that they dealt with became more complex because computers were getting faster and they were able to solve more difficult problems. And so initially they had the stuff that, like what we've done so far, they said, I need to run this calculation. And so they'd create a method and stash it at the bottom of the code. And whenever they need to call that method, they'd call it. And they'd say, oh, I need another bit of code to run here to do some calculations. So they'd create a method and stash it at the bottom. All right, okay? But even then, you still got situations where you're writing a code, you jump down to here, and then you jump back up here. Then you jump down there, and you jump back up here, okay? And we're talking about code that would be files and files, pages and pages and pages long, some of these. I mean, tens of thousands, hundreds of thousands of lines of code just, to do some, what we would call basic stuff, okay? And so they needed a different way of breaking the problem down than just to say, do this part over here, do this part over here. And the way that they solved that was by thinking about the problem in terms of objects. And say, we need this object, and we need this to take care of this part of the problem. And we need this object to take care of this part of the problem. And we need this object over here to take care of this part of the problem. And then in the process of them solving the problem, they will talk to each other, okay? So we need, for instance, maybe say the problem was something with the bank. You wanted to create like a bank program to be able to do different sorts of stuff. Where you'd have one part of the program, one object would be like mimic all of the stuff of a teller, of someone at the bank that's talking to you. All right, so that would be the teller object. And you'd have the code for the teller object would just be in the teller file. But then you'd have another one over here that was maybe like somebody else at the bank might be the bank manager. And you'd have another bit of code that would be like the bank manager or the loan officer. And so that could interact with the user. But then maybe both of those objects could talk to each other. And then you have another object over here, which was the vault, which stored all the passwords, kept track of all the money and the savings accounts and stuff like that. And so then if the user was interacting with the program, they would interact with the teller object and maybe say, I want to transfer this or move this or pull this money out. Then the teller object would talk to the vault object and exchange stuff like that. And if the user wanted to do something really special, like create a new account, they're talking to the teller object, and the teller object would talk to the bank manager object and get the permissions. You see what I'm talking about? So you break the program down into objects, and it's very clear this object deals with this stuff, this object, and they talk to each other. So that's called object-oriented programming, where you're thinking about the problem in terms of objects. All right. So, what is the difference then between a class and an object? So, just to wrap this, if I were to ask you then the question, why use classes and objects? Historically, the why was to make programs easier to write, to make them easier to solve, to make it a little bit more natural in terms of the code. That's because the code was getting way too long. So that's what kind of started this whole thing. Before we actually look at some of the code, though, the next question is, what's the difference between a class and an object? And the best way I can explain it to you is with the diagram there. A class is like a blueprint. An object is like a house. Okay? So the class is the code that's going to define the properties. The class is the code that's going to define the methods, the things that it can do. Okay? In our bank example, the teller, okay, might have properties that talk about, say, how many people it can interact with at a time, okay? Or it might have properties like opening and closing hours and stuff like that. The methods are the things that it can do, okay? And that's what the class code is. The object is the actual physical thing in memory which stores the pieces of information, okay? So let's go talking about with this in a house. So with the blueprints tell you there should be a door here, there should be a door here, there's a window here, there's a window here. This side is 20 feet, this over here is 10 feet. Okay, there's stairs right here, they're this far away. It's telling you all the properties, okay? And it's telling you all the ways in and out of the house, where the electrical lines are, where the water lines are. The actual house implements all of that stuff. It's an instance of that. And here I kind of picked this picture right here because all those houses are pretty much, y'all see a lot of similarities. They've all got kind of like a window up here. They all have some sort of deck. They all have stairs going up to the front porch, okay? But what are some of the things that are different in those houses? Rigel?
What are some of the differences?
Yeah, what are some of the differences?
The colors.
Okay, the colors. If we were to go inside, probably see different furniture, probably see different people inside.
The windows are different.
Yeah, so you get some slight variations on the shutters and some of those decorations, stuff like that. But the blueprint is still the same, okay? So the code behind those is all the same, but the actual values in the properties are all different. So they all have code that says you have to have a front porch, but then they all have leave some room for variation. You could be like, okay, but your front porch color can be blue or red or yellow or whatever, okay? And so those would each represent objects, because the object is going to store the data, and it's going to use the methods to communicate with other objects. The other thing that we're going to see is you are just create one class, and from that one class you can have 1, 2, 10, 20, 30, 100, thousands of different objects. And they could have the same values, they could be different, it could be totally customizable within the class framework, okay? Depending on what the properties and stuff were. Okay, so what's the difference between a class and an object? See, maybe the class is the blueprint of the code. The object is like the house, or the houses if you have multiple objects. All right, so what does a class and an object look like in Java code? All right, I think in your on your handout there, I want you to put the name of the project and the name of the files that we're going to create, okay? So let's go ahead and open up Eclipse. Now all of this I've got on the Google Doc, but that's just in case, that's for Lane and everybody else that's not here in my classes. We're going to actually build this all ourselves, so let's go ahead and do it. So let's go ahead and go over to Eclipse. And let's go and make a new project. Where do y'all have all your demos? Is it in demonstrations? I'll call this class and object demos. I'll just make a new project. Alright, let's go ahead and create a new class. And for our purposes, found it's kind of easy to deal with stuff with animals. And I think, now last year we talked about classes and methods a little bit. We're going to go a little more into that, but got to make sure everybody remembers everything. So we'll just do something real basic. We'll have a dog class, and then we'll have some objects, some actual dog objects running around here. So for your class name, let's call it dog. Now, we are not going to click the public static void main string bracket R's like we normally do. We don't need main methods here for our dog. All right. So when you do that, you should be able to just have Eclipse will auto generate the public class dog code there. Okay. Source, hit cancel. Right click over here. Alright, good. New class. Alright. You get it? I don't think it's going to let you have the and symbol for your source folder. Yep, is not a Java project. Okay, hit cancel. Let's go over here. We need to create a new class. You created a project, but it wasn't a Java project. So you say new Java project. Just call it class demo. And then, okay, yeah, not that. All right, we're in. Okay. So, properties. Let's brainstorm. What are some properties of dogs that, things that might change?
Clean or dirty?
Okay. So, clean or dirty? Color. Breed. What'd you say? Size.
Length of their fur.
Okay. So like how hairy they are? That's plenty. Okay, I'm going to add one more to it here. Name. All right. Now, we're calling these properties, and we can imagine that these are all different for different types of dogs and things like that. In Java, they're officially called instance variables. They're also known as fields. You'll see all three of those terms. All right. Now, using what we know as far as the different types of data you can have, strings, ints, doubles, booleans. Let's go through this and tell me, would name be a string, an int, a double, a boolean? It'd be a string. You don't feel like you need to write all these down. We'll just pick maybe 3 of them here in a minute. What about clean? What type would that be? I think it'd be a boolean, like a true or a false value. Yeah. What about color? String. Breed? String. Size?
Int or double.
Well, yeah, how big is, like, what is size, like, what dimension? Length or width or height? See, I feel like it's,
Or weight.
Or it could just be like weight.
you said length?
Weight.
Weight, okay. Yeah, why don't we do that instead? Now, if we're talking weight,
Could be double.
double, what's the units?
Kilograms.
Pounds or kilograms? It's whatever we want it to. We're making this class up. Let's say weight in pounds. Something we can all relate to. Unless y'all know kilograms pretty well, I don't. If I told you go lift 20 kilograms, would that be a lot or a little? What about 20 pounds?
That'd be like.
Can you curl 20 pounds? Can you curl 20 kilograms?
That'd be like 50 pounds.
Okay. So, weight in pounds, what did we say? What type of data?
Double.
Make it double. Alright. I like string name, and I like, Harry, once again, that'd probably be a Boolean, and I like the double weight in pounds. Let me show you how we can create those two properties, those two methods, or sorry, properties, instance variables here in the dog class. We'll just say string name, semicolon, and double weight in pounds. All one word. You want to, it's just like any other variable that you want to have there. All right. Methods. So methods are activities or actions. There's other things too, but what are some things that we would want our dog to be able to do?
Bark.
Okay. Keep going.
Tricks. Be potty trained.
Okay. So we want him to do tricks. We want him to be potty trained. So go potty.
That could be even be a Boolean like is potty trained. True or false.
That's true. Yep. I like what the is in front of it. Is potty trained? Yep. I gotta kind of limit ourselves because we're gonna have, and here in a minute after we have the blueprint, we're gonna need to create some actual dogs too. Okay. Give me one or two more. What are things you want? What's that?
Eat.
Eat. What else do dogs do?
Sleep.
Sleep. Chase cats. Okay. All right. I like the bark, and I like maybe eat. I like that because later on we can modify the weight in pounds. Because whenever you would eat, then that would change this. Okay. If we want our dog to bark, does he require any extra information?
No.
Yes.
I have to go do that veteran thing after lunch. I forgot all about it. And
Right.
They just texted me.
Have they left?
Yeah.
Really? You need to go. Go for it. That's fine. All right. We're not going to need any extra information. We're going to assume right here, and also these are not going to return any values or anything like that. Okay. We're going to make all these void just for the sake of simplicity. All right. So we'll go ahead and write these two methods. So we'll say public void bark. And public void, what was it, eat. Alright, so you see, I'm calling these void just because right now we're not going to mess with having it return a value and stuff like that. We dealt with methods that return values before. When we get back from Thanksgiving, we'll write methods that take parameters and return values, but right now I'm just interested in classes and objects, okay? So if our dog's gonna bark, we'll just say system.out.println. What? Louis, this was yours. What could it be? Rough, bow wow,
Wolf.
woof. Okay, I love it. All right. What about when he eats? Should he say something? Let's say system. What is it? What does the dog? Does he make any sound when the dog eats? Can he say yum? And what I like about this is it actually kind of makes sense. Would his properties change? Would his name or his weight change when either one of those methods occurred? One of them might. His weight might change, right? So, whenever he eats, let's make his weight in pounds go up by 1. All right? So we'll say weight in pounds. Anybody remember how to make the variable bump up by 1? Plus plus. Perfect. So on your paper here, when it says what does a class and an object look like in Java code, go ahead and write the name of the project there that you have, as well as the Eclipse file that you've got going on there. So in mine, it was class and object demo for the project, and this one is in a file. Notice it's dog.java, and that's one of the things. The file name has to be the same spelling and everything else as the class name right there. So this is the dog class. It has to be in dog.java. Like I said, as always, Java is case sensitive. All right. Go ahead and save that and run that. Let's see what happens. So what happens when you run that? Can you run it?
No, it just keeps popping up when I add previous.
Okay. Robbie's is running one of the previous programs. Does that happen for anybody else?
Yes.
Can anybody get this one to run? No? All right. So
Yeah, make another.
yeah, we're gonna make another one. When we hit the run button, so just a little reminder. What does Java look for? What method is it looking for when you hit the run button?
The main method.
It's looking for a main method. That's the entry line. Do we have a main method here in our dog class? No, we don't. So the point of entry, so this is literally just a blueprint. We're going to create another class that's going to have all of our dog objects running around in it. Okay? So within that same project, let's right click over here and say new class, and we'll call it kennel, since that's the logical place to have a bunch of dogs. I guess we could call it the dog park. I don't know. I think a dog park's a little bit happier of a place than a kennel, don't you think? Okay, I'll make a dog park. However, class names, you cannot have a space in between them, just like variables. So you have to make it all one word, and we'll do camel case there with the uppercase and second letter. This one, do check the public static void main string bracket args. And you should have something that looks like this. And go ahead and put that, whatever you named it, put it there on your list. You want to make sure you do dog.java, because that's the actual one. This would be dogpark.java. Okay. Another thing, normally, it's kind of an unwritten rule in Java, and that is that you make your classes uppercase. Now, for the first letter. Robbie, I saw that you had dog park with a lowercase d.
Yeah.
Yeah, that's not going to break your code, but it is standard policy for that first letter to be capitalized.
Okay.
So just so you know. Alright. Let's go ahead and make ourselves a couple of dogs, shall we? We'll make one dog first, then we'll do it with another one. So we'll say dog D1 equals new dog. Open paren, close paren, semicolon. Now we can try to get real fancy here. Is that too fancy? Yeah, that's a little too fancy. Alright, there we go. We have just created our dog object. Let's go and change some values. D1.name equals Luis, it's the name of our dog. Could be a famous dog, could be Scooby, could be Snoopy. Carl. We'll take it. D1 dot weight in pounds. You'll notice there actually it'll auto fill it in if you just hit tab and enter. I don't know, any dog owners out there? Some standard weight of a dog.
It depends on the size for each.
Well, according to Ron Swanson, anything less than 40 pounds is a cat. If you're familiar with that. So we'll say 45 pounds. Maybe he's anything less than 50, I can't remember the exact quote. But anyway, he weighs 45 pounds.
What about a 39-pound dog? That'd be like a giant cat.
It would be. And we're going to say D1 dot bark. And D1 dot eat. So there we go, we've just created our dog, we've set some of the properties, and we've told it to do a couple things. Let's run that code and see what happens. Alright, why does yours look different? Fidel? Alright. So mine's on 2 lines. Anybody get theirs on 1 line? See a couple on 1 line, on 2 lines. Yep.
Oh, there, I fixed it.
What was the issue?
The system out print line up. I didn't have the line.
Okay. Did you get that? Alright, print line right in print. Okay. Alright. So, we've answered number 3. What does a class and an object look like in Java code? Well, here's what a class looks like. Come on now. That's what a class looks like. What does an object look like? Technically, this line right here is enough to create the object. That's the object creation code, everything right there. All the rest of this stuff is customizing it and having it do some of the stuff. So there's your answer number 3. What are the parts of a class? That's question number 4. We've already answered that, okay? And it's these 2 things up here. The 2 parts of a class are the properties, aka instance variables, aka fields, and the methods, aka activities, aka actions. Those are the 2 parts of a class. Alright, so next question there says, how can I see or change the properties of an object? Well, we already did that right here. On mine, it's lines 7 and 8. How did we change those properties, Robbie?
What?
How did we change the properties of our dog object?
I was writing in what you want them to be.
Yeah, okay. And if you notice, we have here, this is the object, D1. Then we've got the dot, and then we have the property name. okay? Or we call the instance variable, okay? Here, and then we set it to whatever we wanted it to be set to. So the way that we are able to change any of the properties is object, then the dot, then the property that you want changed, okay? This dot right here, it actually, the period or whatever, it actually, this thing has a proper name. It's called dot notation. All right, we've been using it since day one, but that's what it's called. So the question was, how do you change the properties? Well, you have the object. We'll say the object name dot property name. That's how you access it. Let's say I wanted to print out the dog's weight before he eats and after he eats. Okay? So we can do that. In between the bark and eat, I'll say system.out.println I weigh double quote D1 dot weight in pounds. And then we'll copy that and then paste that same line again right there. So this is the way that we can access it, we can read what that value is. It's the same notation that we use for changing it. Anytime we want to access those properties, we just put the object name, then the dot, then the property. So, Alan, what do you think? You're running it, have you? You ran it. Fidel, you ran it? Alright, so Fidel, you're making a prediction for us. What do you think this is going to print out? I weigh. Okay? And then, keep going. What do you think it's going to print out down here? Why? Yep. So when we execute that eat, if you all remember, we've got that plus plus code. It should bump it up, and then we should see that reflected here when we print out that value. So Wolf, I weigh 45.0. Yum, I weigh 46.0. All right. So here at the end of class, when you're writing an ogre, designing an ogre, you can think about this in sort of like maybe hit points, or any of those properties could be something like maybe health or maybe experience, right? And so you could have those methods could change those properties. And for your modern games, every object has 10 or 20 or 30 different properties, and how it react. Some characters have react differently to different enemies and things like that. So anyway, this is a real quick way that we can kind of visualize how those changes go on. So the question was, how can I see or how can I change those? Answer, using that dot notation. Let's turn the paper over, see what else we got. How do I talk to an object and tell it to do something? Robbie, how would you answer that question? How do we talk to our object and tell it to do something?
By putting in the object's name and then an action, like what you want it to do. Like, for example, D1.bark.
Yep, that's exactly right. Only thing I would add to that is just make sure you put that dot in the middle.
Yeah.
Yep. So the answer is pretty much the same. If you want to access the properties, you put the object name dot property name. If you want to talk to the method, then you say object name dot method. I'll even put dot method name since that's the name of the method. And then remember, with methods, you're always going to have parentheses there at the end as a way of distinguishing it from property names. And later on, just like we did last week, we will create some methods that require extra information, but since today we're dealing with the classes and stuff like that, we're just one step at a time here. All right. The next question is, what does it look like in memory, so in the RAM, when I create an object? Okay, so when we execute this line right here, dog D1 equals new dog, what actually goes on inside the computer? And I'll show you that. So first off, it says D1, so Java is going to create a variable called D1, spot in memory for it. This is the left-hand side of the equation, okay? And then over here on the right-hand side of the equation, it says new dog. So in memory, Java carves out a spot in memory big enough for a dog. I'll put dog right here so we know that it's what it's for. We know that a dog has two properties, the name, and I'm just going to put weight, W-G-H-T, just for time's sake here. And then it sets that D1 variable equal to that spot in memory. So if I were to say, trace through this code, show me what's going on inside the computer behind the scenes, this is what you would draw. A reference named D1 that points to a dog object, and that dog object has two pieces of information. Now after we run our next two lines, we can actually put Carl on the inside for the name, and 45 right there for the weight. Luis, do you remember kind of discussing some of this stuff last year? Good. We didn't get anywhere near as detailed as we're going to get even as we are right now, so that's good. All right. How do I create more than one object? Okay, so this would not really be much of a time saver, you know, in terms of code if we every time we wanted to write a new object, we had to write a new class. The thing is, like I said, we can create 2, 3, 10, 20, or even more objects from one blueprint, from one class. So let's go ahead and do that right now. I'm just going to keep the same dog park file. And just a little bit farther down here, I'm going to have another dog. I'll say dog D2 equals new dog. D2.name equals popular dog name, folks. Matthew, what do you got?
Buddy.
Buddy. There we go. Oh, I said D1.name. I should have said D2.name. D2.weight in pounds. Buddy weighs in at a strapping 60 pounds. We can say system.out.println my name is d2.name. And then I'll copy this other one up here, system.out.println I weigh d1.weight pounds. But instead of saying D1.weight pounds, I'll change that to D2 weight pounds. While you're getting that, I'll just go ahead and show you. You can imagine, what does that look like, that second object? Well, it literally looks like this. D2, spot in memory. Java carves out a spot that's big enough for a dog, which means it has two spaces for properties. One of those properties is the name property. The other property is the weight property. And then it has D2 reference that spot in memory. And then after the next two lines, we actually fill in those properties. Buddy, and what do we say, 60? Oh, those are not in quotes. Sorry about that. I put these in quotes earlier. They're not in quotes because it's not a string. It's a double. So what I want you to see here is that D1 and D2 are pointing to two separate locations in memory. Their values are not linked, okay? There's no connection. We can talk to D1 and we can tell him to do stuff and things will happen. We can talk to D2. We can tell him to do stuff and change his values. It's like you're playing a video game and you've got two enemies that are both the same type of enemy, okay? But one's over here and is like red, you know, ninja colors, on the other here is green and green ninja. And you're fighting both of them. They both have the same properties, but this guy's health is, you know, down to like 5. This one over here has a health of 100. Okay, so those properties are different, and it's based on the fact that I'm attacking this guy more than I'm attacking that guy. Right? It's the same exact type of code that's going on there. Okay, we're gonna hit run, and I'll walk around and see if anybody has a question. You should get, I weigh 45, Yum, I weigh 46. Then my name is Buddy, since we're talking to D2, and I weigh 60 pounds here. All right? So, this last part here is for you to take care of, and when you walk in tomorrow, I'll just go ahead and bring this back to me. I want you to create, I want you to design, it should take you maybe 5 minutes tops, an ogre class. Give me some instance variables, 3 or 4. Like I said, strength, okay? Give me the type. And then give me some methods. I've got attack player, but what are some other things that an ogre can do?
Exact one last year.
Was it an ogre?
Yes, it was.
I can't remember
And
exactly
I
what it was.
basing off of Destiny.
Oh, that's what it was. Okay. Anyway, so give me 3 or 4, at least 3 of each, all right? All right, so today we talked about classes and objects. We kind of looked at all of them, why we use them, what their makeup, how they look in memory, and even the Java code, all right? Thanks for watching.